Okay, I'm looking at number 1 on the review. They give you the position function s of t is equal to the square root of t squared plus 1 meters, and they ask you to compute the average velocity over the time interval from 2 to 5. So the formula for average velocity is s of t1 minus s of t sub 0, or t naught, over t1 minus t naught. So you need to compute, that's going to be, this is t naught and this is t1. So it's going to be s of 5 minus s of 2 over 5 minus 2. So s of 5 plugged into this function is going to be 5 squared plus 1. So that's going to be the square root of 26 minus the square root of 5 divided by 3. And so you can type, if you want to get a decimal approximation to that, into your calculator, square root of 26 minus the square root of 5, and then you want to divide that by 3. So it's 0.954. That's the average. And that's going to be meters per second. Now, then it asks you to find the instantaneous velocity at t equals 2. So you need to find some intervals around 2. So you might go on either side of 2. So you could do 1.99 to 2, 1.999 to 2, and then you could do 2.01 and 2.001. 1 to 2. Oh, sorry, obviously, whoops, silly, on the other side. So from 2 to 2.001, and then 2 to 2.0001. Something like that would be good. And then this is kind of clever how you type this into your calculator. I like to use the list feature function. And you can go into edit your list, and in L1, oops, sorry, math, no, sorry, you do stat and then edit is choice 1, and then we can edit our list. So clear this out, and then in L1, just put the left-hand endpoint. So we had 1.999, and then 1.999, and then 2, and then 2. And then in the L2, put the right-hand endpoints. So this would be 2, 2, 2.001, and then 2.0001. And then in L3, go ahead and plug the formula in terms of L1 and L2. So you're going to do a parenthesis to get the numerator, and then you're going to do second square root, and you're going to do L2 squared. So you do second L2 squared plus 1. So that's like s of t1. And then you're going to subtract s of t sub 0, which is the values that you have in L1. So you do second 1 to get L1, and then square it, and then plus 1. And then you're going to divide that by the length of the interval, and you got to put that in parentheses. Oh, and I missed my parenthesis in my numerator here. So put another parenthesis, and then divide it by parenthesis. It's going to be L2 minus L1. So second L2 minus second L1. Close your parenthesis and hit enter, and it's going to automatically do all those computations, and you can see that it's about 0.8943 looks like the value that you'll get for the instantaneous velocity over the interval, or 8944 meters per second.